Good morning, children. Welcome to the chemistry class. Today I'm going to start new chapter, chapter 4, structure of the atom. And this is the last chapter of your chemistry syllabus. Now, first outline of the chapter. What we are going to study in this chapter? We are going to study about subatomic particles. Subatomic particles means particles which are smaller than atom. Electron, proton, neutron we are not going to study here. Then we'll study structure of the atom. We're going to know about two important models, Thomson model and Rutherford model. Then Bose model, this is very important model. Then this is also a model about structure of the atom, how electrons and protons are distributed in the atom. Then electron distribution, how they fill up in different shell. Valency, about valency you know well. Now how valency is decided or how you come to a particular number, that we are going to study. What are atomic numbers and mass numbers, and about isotopes and isobars. So these are the topic of this chapter. Okay, so we'll start with failure of Dalton's atomic theory. In the starting of this third chapter, we have studied about Dalton's atomic theory. Most of the points are true or successful in Dalton's atomic theory, but one very important point, that is atoms are indivisible, is not okay with what we know today. Why? A series of experiments, study of static electricity, came to the point that there are particles which are smaller than atoms. There are particles exist which are smaller than atoms. They reside inside the atom. Study of static electricity. That means, for example, when you rub a dry comb on your hair, comb on dry hair, and you can attract bit of particles. That shows there are positive or negative charges. Similarly, when you take a wooden rod and rub it on silicon, it also acquires charge. That means the charges can be separated. Atoms are not indivisible. You can separate charge. So this type of experiment leads to the thing that atoms are indivisible. This is wrong. Atoms are divisible. They contain some more particles in it. This static electricity experiments lead to discovery of electrons and protons. So mainly you have two charged particles and one neutral particle. There are mainly three subatomic particles: electrons, protons and neutrons. Electrons are negatively charged particles, protons are positively charged particles, and neutrons, they are neutral. There are more particles. This is the case few years back, but now we know by research, by papers, by experiments, that there are particles even smaller than this electron and proton. They exist, okay, like quarks, bosons, and God particle. If you know, there are at a very large scale. This experiment is going on to know about this God particle, and they are successful in that experiment. So they know, okay, there are particles which are even smaller than electrons and protons. They also exist. Okay, so electrons and protons, you can say they are also not indivisible. There are particles smaller than them also exist. So this study of static electricity, it leads to discovery of electrons and protons. Electron is discovered by J.J. Thomson, and this is around 19th century. And this proton is discovered by E. Goldstein. Okay. Now this discovery, okay, now they know that electrons and protons, atoms are not divisible, atoms are divisible, and electrons and protons, they exist in that. But then how are they distributed in this atom? What is the structure of atom? That was the question going on in the mind of scientists. So many experiments, at that time they did many experiments, they gave different models, and out of that two important models, Thomson model and Rutherford and Bose, these three we are going to study here. The first model was given by J.J. Thomson. What he said is, the structure of atom is like a plum pudding. The plum pudding is a sweet dish type of thing which has plums inside. Or better, you can understand this model as a watermelon model. You know how watermelon looks, right? So you have a red part, fresh part, and seeds in between. So Thomson said structure of atom is similar to this type of model, where this red part, you see, this denotes the positive charge particle, and the black seeds, they denote negative particles, that is electron. So what he said, the structure of atom is such that you have everywhere the space is filled with positive charge particle, that is protons, and in between them what you have is electrons, and they are distributed in such a way so that number of electrons is equal to number of protons. So as a whole, this system is neutral. So if you have 5 electrons, then the charge distribution of proton is also 5. So that will cancel each other. So this is the model given by J.J. Thomson. But then Rutherford, he did gold scattering, gold foil experiment, and he tried to explain that experiment result, what he got in result. He tried to explain using this model, Thomson model, but he failed to do that thing. So he thought this model, it has some problem with it, because if model is okay, then if someone is proposing some model, okay, then that model, if it is right, if it is true, then it should be able to explain all type of experiments related to this like electrons and protons. But whatever experiment Rutherford did, he was not able to explain finding of that experiment with this model. So then Rutherford proposed another model of structure of atom. Now Rutherford model, that we will study next.